Hello and welcome to Differential Discussions. I'm Melissa,
And I'm Dave.
and we're going to continue talking about red cell morphology. And today we're going to talk about hereditary spherocytosis.
Hereditary spherocytosis is really cool. It's cool from my perspective, not cool from the patient's perspective, but one of our inherited hemolytic anemias. So we're looking at a field that I think is fairly representative of hereditary spherocytosis. It's a tad faint. This slide is probably starting to get a little bit older, but I see a fair amount of polychromasia, and I see some spherocytes.
Yeah, and I think the level of spherocytosis, or the number of spherocytes, and then accordingly the number of polychromatophilic red cells will depend upon the severity of the HS that the patient has also.
That's a good point. So here we have a lot of genotypes for this particular spectrum of phenotypes even, right? So so pathophys. So how does someone develop, or as a consequence of their inheritance, they have problems with their, what is it, the vertical linkages?
Yep, the vertical linkages between the cytoskeleton and the membrane of the red cells. So what happens then is that the membrane is not anchored onto that cytoskeleton like it should be. And so pieces of the membrane are allowed to just kind of slough off of the red cells. And so what does your red cell do? Well, it's just going to reform the membrane, make it a little bit tighter. And so you have less surface area now to your membrane, but you still have the same volume within. And so that gives you a slightly more microcytic, not truly microcytic. I mean, that depends on how the severity again and how much of the membrane is sloughing off. But a regular old spherocyte is not necessarily microcytic. It depends on how much of the membrane is taken with it. But because you've decreased the surface area, you've made that cell more rigid, less flexible, and it can't squeeze through the small spaces like it needs to.
Right. Yeah. So it takes on the most volume efficient shape known, right? The sphere itself. And how that represents on the slide here is as you get a biconcave disc to then sphere up, one of the consequences of that is now the light path is going to travel through more hemoglobin, right? So we have roughly the same amount of hemoglobin in the spherocyte as its biconcave counterparts. And as a consequence, you get this more deep red, right, Melissa? So that's kind of like what my eye looks for first, is that deep red.
The deep red, and then less central pallor.
Exactly. Yes. Yep.
Sometimes none. It just depends again on the severity of the spherocytic nature of that cell.
Right. And so polychromasia too, very common to see. So where does the polychrome come from?
Yeah, so the polychromasia comes from basically if the bone marrow is responding, it's going to push out stress retics. And that's what our bone marrow retics are called, stress retics. So when they're pushed out into the peripheral blood due to stress on the body, you get polychromasia, or a lot of polychromasia. And so it's typical to see that in our hemolytic anemias, especially when the bone marrow is responding. And I say that because the bone marrow doesn't always respond, which is then a different issue. But if the bone marrow is responding, there'll be polychromasia.
Cool. So do we dot all our I's and cross all of our T's?
I think so.
So we can kind of maybe take a spin around.
Yep. So just playing with the fine tune a little bit. Right. I think that's better. All right, so let's find some spherocytes in here. So there's a nice one right here. A nice spherocyte that lacks central pallor. It's got that nice deeper coloration, like Dave was saying earlier, to the cell.
I'm going to now use my newfound abilities here. Woo! Oh, I can see yeah, there we go. So, that one kind of looks, like a spherocyte.
Yep.
And like a lot of things in heme too, like when I start to see spherocytes, I become more sensitive to other spherocytes, right? You start to try to look for those findings more.
Yeah, then you can actually see them more. But yeah, it kind of looks like this guy down here is one too.
Agreed.
And this one I would say is more of a microspherocyte.
It does look a bit smaller, doesn't it? Huh? Yep.
Mhm.
And then other morphologies in hereditary spherocytosis, I don't know that there are many other morphologies that could be associated with HS. There might be others that are incidental, but
yeah, I mean, I think you could find the occasional schistocyte, but I think for the most part, it's going to be spherocytes and then our polychromatophilic cells. So let's clear these. And then we have our polychromatophilic cells up here, which they actually look really nice on this.
They do.
Screen.
We actually have really good contrast on the poly. Sometimes poly's hard to pick up.
Yeah, it is.
It can be a little tricky. So yeah, this is pretty cool. Kind of a textbook HS.
Yeah. Yep. And just for reference, for those of you who don't know, polychromasia is this kind of purpley color because your hemoglobin stains this kind of pinky salmony color, and RNA, which reticulocytes have excess RNA in them, they stain a dark blue color. So when you mix blue and pink together, you kind of get this nice purpley color, which is why reticulocytes look like they're that purple.
Yep.
All right, let's move. Oh, I jumped.
The neutrophil almost looks hypogranular, huh?
It does. I wonder if it's actually hypogranular or if the stain is just kind of.
Might be an older slide, yeah.
Not very good.
Get some platelets in the field too. And this field kind of confirming findings from the previous field, right?
Yep, absolutely. A few spherocytes, some polychromatophilic red cells, and that's about it. Not a whole lot exciting with this.
Yeah.
The key, though, with the spherocytes is to make sure that you're not on the edge of the slide towards the feathered edge, getting those spherocytes where they're not real spherocytes. It's just you don't have enough red cells together, and so you kind of smooge them and smear the hemoglobin throughout the whole cell so that it makes it look like they're spherocytic, but they're really not. So the key is to make sure you're not in the feathered edge and to make sure you're actually in the good part of the slide. So let me just move towards the feathered edge.
I think that's a great exercise. Yeah. Sometimes I forget what we're really setting out to do here. And it's tough as I'm practicing as an experienced morphologist to kind of remember the mistakes that students can make and the confusion that can kind of ensue. Yeah.
Yeah, definitely. So it looks like there's more. Like it looks like this is a spherocyte almost. It looks like these are, even though they're big, sizable cells. Yeah. They look spherocytic, and spherocytes are not usually that large.
Right.
Like this guy looks like a true spherocyte.
Exactly, right? Yeah, that's an exaggerated real spherocyte.
So then comparing, this real one here to these pseudo spherocytes that we have, you can tell that when you go too thin on the slide, this is what they look like. It looks like, oh wow, there's a whole ton of spherocytes here, but it's just you're in too thin of an area.
Mm-hmm. Yeah. So and part of the skill is detecting when you're in like a poor area, and we can kind of like give you like tips about that. But one of the things that sticks out to me, so like in this field in particular, the orientation of these red cells right here, that to me looks completely unnatural and not a random distribution of how the cells would. So they're kind of being like forced into so when you see patterns like this,
yep,
go thicker, move thicker. And also always start on 10x, 20x, whatever your scope's equipped with. I mean, I can't stress that enough for finding a good area. And we have a video available if you dig through the
I'll link it.
Yeah, thank you.
I'll
Thank you,
link
Melissa. For finding a good area. Helpful tips.
Yep, absolutely. Because this is the bad part. So you want to go thicker, but you don't want to go too thick because then it looks like you have rouleau.
Yes, right.
So don't go too thick. But I think it's important to show the thin area to show the difference between true spherocytes and pseudospherocytes because you're in too thin of an area. So, you know, in the thicker, let's go back a hair thicker just so we can kind of give our final grading on it.
Sure. Good.
Cool.
All right. So if I'm trying to hit those 5 or so cells per field for polychrome, I think we comfortably do that.
Yeah.
What do you think?
Yep.
Yeah. That seems to be pretty consistent.
Yes. And that's the other thing with morph is being consistent. So we've looked at, I mean, we've only looked at like 3 fields, but this one is pretty consistent, which is nice. And there's not a whole lot of variety, but you know, for practicing, especially make sure you're looking at multiple fields out there. Don't just look at a few.
My label always goes where I don't want it to go. Thank you for cleaning that up. A really good spherocyte, right?
Yep.
I think trying to be, yeah, there we go. I think the one above touching the top of the S there.
Yep.
Trying to find like really, really good ones.
I was just going to say that one's a good one.
Mm-hmm.
Maybe this one right here is a good one too.
Yes, agreed. Mm-hmm. And then maybe put it below, so just touching the one above that S right there, maybe. So I think we're getting to a pretty stable number for a 1+.
Yeah, I agree. And again, the amount of spherocytes is going to come back to the genotype of the patient, giving how severe is that phenotype. So there's a lot of genetic variation, like Dave was saying earlier. So it'll vary by patient, how many spherocytes they have. Some may only have 1+, like this person, and then some may have 2+ and a lot of spherocytes. And if they have a lot of spherocytes like that, they're going to have a lot more polychromasia because they'll have a lot more of a hemolytic process going on. So it'll just vary by patient with HS. Well, I think that's everything then. So thanks for watching.
Yeah, thank you. Please like, subscribe, and hit the bell if you'd like notifications whenever we post a new video. And feel free to reach out to us on social media or via email with comments or suggestions about future content. Thanks.